Hello and welcome back to Compiler Programming. We left off the last video with being able to parse and understand this function, but a lot of the parts there are very not robust, let's just say that. And in particular, what I want to address today is the part about types and looking up things by names. So this is not something that is viable long term, especially when we want to start to allow people to introduce their own types. So it is worth to look at it already now, and it's also something that prevents us from having things like parameters to the functions or imports or anything to that sort. So we are going to talk about scopes. And if you programmed in any kind of recent programming language or generally programming language, you're aware what those are. So you, for example, each of your functions usually has a scope. So when you define a variable inside of the function, this variable is only accessible inside of that function. Now there are some weird languages. I think Lua has lexical scoping. So like in the function, you can access variables from the parent, like the function that called this function, stuff like this. But this is very rare in general. It has more disadvantages than advantages. Let's just put it that way. So pretty standard way is you have some kind of definition of a block, whether it is a function block or like at least in C, you can just create a block, right? Or if when you write if or something like this, you automatically end up with one. So if you put some variable into here, then you will not be able to access this variable over here. And you generally have something like in C, you just have a global scope. So anything that happens outside of these functions is going to be inside of a global scope, so which is shared because you just include files into other files. In more modern programming languages, you would have modules, and you would have like module globals. In languages like Java, you would have package globals where you have like a group of modules together that can access to data. But the general idea sort of stays the same in the sense that you have just a limited scope where you can look up function names. Now the tricky part about this and tricky question to answer, for at least for this language, would be whether we want to put types and regular variables in the same scope, because in C they are actually not. So if I try to build this and just check that it works, I think I can do things like this. And let me try if that works. Yeah, so I can do it. And this is pretty interesting, right? It's not something that you would write very often, I guess. But it is valid because the type U64 is separate from the like a variable name U64. And it is an interesting question to answer. Like, do you want it to be that way or do you not want it to be that way? Eventually, I want to have reflection in the language and being able to work with types. So I think we will just put types into the same category as everything else. So you will not have a separate scope for the types, but I thought I would explain this before I do this, because it's also a behavior that, for example, someone coming from C would find very surprising. Okay. Anyhow, so what is a scope? Well, let's just start defining it. And I like to start definition with data because that's what it is all about. And scope is a pretty simple construct. It just has a parent. So you have a scope star parent, and then you need to have some kind of hash map or any other map from names to something. And that something is an interesting part. And this is also where the question about types versus values becomes interesting. So right now, we don't really have a value that has a type of type, but this is something that we will have to introduce now to make all of this work if we don't want to have separate scope for types. Yeah, so we have scope map and we have like items. It doesn't really matter what we call this one. So we don't have a scope map, but I do have a simple hash map implementation that I wrote in C that we can use. So we can say hash map slice template, and it will be scope map. And we also need to provide the type of the value, and type of the value will be value star. So we will go basically from slices to pointers to values. This is what our map will work with. Okay, let's check if this works. Yeah, we need to change this to be struct scope. And I think we also want to do it this way. This should probably be a pointer. Okay, that sounds good to me. Now we need a few methods to work with this stuff, and this is where we can actually put some tests into our source spec. Maybe let's wrap these tests into say that this is tokenizer, right? So whatever all of these is just all about tokenizer. And we will also now add some tests for the scope. Okay. It should be able to set and look up values. Okay, so what does it mean? Well, it means that we can do value star test is value from S64, and it will be 42. Now we will need to create a scope. Actually, it doesn't matter in which order we do it. I just say scope root scope, and well, we can just initialize it with the items for now. We'll figure out if we want a custom initializer function later on. For now, this is perfectly okay. And items is a hash map make of scope map. Okay, now we can say hash map set root scope items. I actually don't like items. Let's call it map. Okay, root scope map, and then we need to provide a key for the storing it. So we say that we will call it tests as well for our scope, and then we put our value, right? So this sounds pretty good. And now we can say hash map get root scope map slice literal test is I want to check that it's basically the same thing. Okay, is this actually I think it returns the right thing. Okay, void star unknown size. It's interesting. Okay, so I think MSVC for some reason is not happy with this nested describe, so let's just remove those for now. I don't want to deal with the testing framework stuff, so I'll just add a comment. Scope. It's tokenizer. Okay. Yep, misspelled this, and here I do need to have this stuff. Okay, this doesn't actually test anything interesting. We are just testing the hash map, but it's also good test to make because you need to make sure that you initialize it correctly and stuff like this. So let's do that. Okay, but we want to hide this stuff into some kind of more reusable code. So let's take this stuff and start working on our code that is closer to what we'll actually use. Well, the first thing is we'll need something like scope make, and doesn't really accept anything. We will just use a temporary allocator, or we can give it an allocator to create something, but we use temporary everywhere, so just let's stick with temporary. That means we need to change this stuff slightly. Scope star root scope is I think I actually have a convenience macro for this where I can say allocator make scope and then this stuff temp allocator. Do I have something like that? Apparently I do not. Okay, let's just write it out fully. It's fine. Let's go temp allocate of scope, and then we say scope. This is no longer root scope, is this stuff, right? Okay, so that's nice. We can be explicit about this, although C should be handling that for us. And we're just gonna return scope. One thing we can do is to pass in a parent to this stuff and say scope star parent, and here we just say parent. That maybe is better. Okay, I don't need this stuff here. Good. So this is just creating a scope and putting a parent to it. Next thing is we want to have something like scope star, or actually value star scope lookup, and this is going to take a scope and it's going to take a slice and it will give us a value or null if it's not found. So here we have scope star scope. and we have slice name. Okay, and we basically just do that. Return scope. Yep. Okay, that is good. We can say scope set, and basically it's just a wrapper stuff for our hash map, but I think this is something that is necessary because we're gonna use these methods a lot, and it's gonna help us long term to survive this stuff. This is not lookup, this is scope. Let's call it define. Illegal indirection. Yes. Because this stuff does not actually return things. It's a void. Okay. So now we can use this stuff here and we say scope star root. Scope is scope make of 0. And then we say scope define this literal test. And then this one we can change with scope lookup and this stuff. So nothing really fancy, but just trying to make it easier on ourselves to deal with this stuff. And as far as lookup goes, it's also something that would be actually important in a second. So let's try to run the tests. Okay, we haven't screwed up anything, which is always great to know. But the second thing is the whole reason why this is a scope data type and we are just not using directly a hash map is because you expect the behavior of looking into parent scopes, and this is why parent is there, right? If I go back here and I look at this stuff, for example, right? I am inside of this scope, but I'm accessing something from all the way from the global scope. And like you always go back. But if I redefine it, then I can access this redefined version. And there is a lot of argument to be made whether you should or should not allow shadowing of things from the parent scopes. Like you could technically build a system where like it's not allowed, but this is an argument to be had at a separate time. As far as the data structure is concerned and the algorithms are concerned, you still need it because things just won't work otherwise. Okay, should be able to look up things from parent scopes. Okay, so we have root scope, we have scope star, scope level 1 is scope make of root scope, right? And we have scope level 2 is scope make of scope level 1. And now we will define basically a global here, right? So with the root scope, we can also call it global scope. And then we will define some test here, which will be level 1 test. And then we will define level 2 is level 2 test. So basically we just testing that we can access something from all the way to the global scope. We can shadow things inside of the scope. So let's say value star level 1 test is value from 1, and value star level 2 test is this thing. Okay, so this looks good, and now we need to do a bunch of tests. So the first thing is we need to be able to look up a global even when we are targeting one of the nested scopes. Let me check if I'm okay. I have problems here. Okay, good. So this test will fail because we are not actually looking in parent scopes right now. In fact, it actually crashes, which is not what I would expect. So let's see where it does crash. A solution. Okay. We need to change this stuff over here, probably. Yep, we do. Okay, where are you crashing? Whoa. So you are crashing in scope in the hash map get, and why exactly are you crashing? Oh yeah, so that's a good thing, and that we actually caught this. So we say value star result, if not result, return 0, return star result. So because we can store nulls in a hash map, that's a perfectly valid value, and that's why we return a pointer to the value, and the pointer itself can also be null when it's not found. So this is why we need to do this stuff. That's a good crash, my bad. But we still have a problem where we now returned null and we're expecting something else. So that also tells us that we need to do something else here. And what we need to do is to say to turn this into sort of a recursive lookup. We will not actually do recursive function, so we're gonna do a loop, but the idea is you have a scope and you try to look into it. If you were not able to succeed, you will go to the parent one and try to look there. And that goes as long as you either found what you were looking for or the parent doesn't exist, in which case you return 0. So let's do that. We say scope star. Actually, we don't need that. We can do while scope. Okay, we do this. And then we say if result return result. So we're gonna flipping this stuff around. Otherwise, we're gonna do scope is scope parent. And if we got all the way to here, then we basically are done. We haven't found anything. We return this stuff. Okay, that is good. Let's try to run the tests now. And we have them passing. So this is pretty nice. Also, notice that I don't really have delete, and delete is also something that is pretty rare to have in a language. Like, I think only basically JavaScript through weird magic allows you to delete a variable, global one, but other than that, it is not a common thing to have. So for now, we will not have it. If we realize we do need to have it, then it is fine. We also need to at some point think what happens when you try to redefine something that already exists in a scope. And this is something to think about. So I will just add a to-do. Think about what should happen when trying to redefine existing thing. Okay, for now that is not a problem that we are having. Cool. So what else? I guess now we need to make use of that. And if we want to replace this lookup descriptor type with something else, there is a bunch of things that needs to happen. Well, the first thing that needs to happen is all of this jazz needs to move. So this actually should be part of value. And the reason it should be part of value is because we want to use it inside of the program. Or actually, we can leave it here for now. That's also fine. What we'll do here is we'll just use struct scope, and I will say the same here, type def struct scope, and we will put the same thing here. Here it's already like that, so that's fine. And that should allow us to say level scope. Okay, and that builds, but that doesn't do anything interesting yet. Actually, maybe I do want to move this stuff. Let's move it here. I've decided I do want to do this. Okay, and then these things will just go into the value C, which we can grab from here and just dump them into here. I guess we might need to redefine this. Yeah, this also needs to go into here. Okay, should be fine. But the whole idea is now our program has this global scope. But just having a global scope is not enough, because if we want to use it to look up these types, as I mentioned, we need to store those types in the scope. And right now, our types are not values. I'm not gonna do it very complicated way to represent types in values. So for now, descriptor type will be just an APEC thing where I would basically let me think about this for a moment. We have values, and values have operands, and operands have types, and well, I guess, yes, we want descriptor type, and this descriptor type will just have descriptor type. Oh, now we have a problem that they are both called type. Descriptor type. let's call it that, although I'm not really happy with its name, but I can't think of anything better at this moment. So type definition, and that type definition will just point to a descriptor. Yeah, descriptor star descriptor. So this is kind of a recursive thing where we say that it's actually we don't even need that. We can just say here struct descriptor type descriptor, something like this. Cool. Have a few places where we need to deal with that. Well, we can put it here. Wait a second. Call the type definition. I do want to call it type. Yep. Okay, next one. That is fine. So we'll tell that I don't know what to do with this for now everywhere. And that is okay. Cool, let's rerun the test. Nothing should happen, but you never know. So that's good. Anyhow, now we can have a special type, and as far as the operand goes, I'll just keep it empty right now. That's fine. So we have operand type. What is value void actually, or void value? How does it look like? Yeah. So this seems pretty okay to me, and our types will do the same. So let me grab that. That will be very useful. We have this program creator. So we have program free, but we don't have program create. That's a bit unfortunate. Well, I guess. How do you want to do this? Well, let's start with doing it in line, and then we will figure out a different way to handle that. So for now, I'm just going to do it here in this test, and I will put to do, move this out. For now, I just want to change this thing and replace it with something better. So let's start with writing the client code. So we remove that function, and we don't know what to do about that. So we need something else. And that something else would be the following. We would say that value star type value is scope lookup of program global scope, and this also going to change, by the way, but for now global scope is perfectly fine. So lookup program global scope, and we need to give it the ID, which is this thing, right? So we assert that we have a type value. We assert that type value type is or descriptor type is descriptor type, And then we say that descriptor is type value, descriptor type descriptor. When you have types represented as types and values represented in types, you always have these very weird sequences of things, but it's, you know, what can you do about that? We need to have this here, I think. Yeah, okay. So this works, at least in the sense that it builds, but if we try to run it, we will get a really bad crash at first. Actually, we don't, which is interesting. So I would expect that we would have a crash here, but apparently, no, yeah. So this is 0 and we have 0, yeah. So that's fine that we don't crash, but we also don't do the right thing either. So let's do the right thing. We say, I can do it. Let's actually move this allocator before here and say like this. And now we can say global scope is a scope make of 0, right? And we need to put some things in the global scope. So how do I want to do it? Well, right now I think I can just create them. Let's put them over here. Value star type S64. Value is ampersand value, and then I have descriptor is descriptor S64 and operand type is operand type none, right? And then we have another one which is S32 and S32, and we need to put them there. We need to say scope define test program global scope, and then slice literal S64 is type S64 value, and the same thing for S32. What is wrong with this thing? This one is something you can understand, and that's all it was. Okay, good. So let's see if that works. And it does not, because here I actually screwed up. This needs to be this thing, which might not work, but let's see. Descriptor type is this, and type descriptor actually is like this, and type descriptor is descriptor type. Does this work? Okay, it does work, so that means I can copy it over here, and this is good. So let's try that again. And we have a winner, which is great. So let's reiterate what happened. Now we removed hard-coded function lookup that we had before for the types, and we can easily add new types and look them up over here or look them up in other places. And this is something that we're going to use later on. You can imagine that now we can start looking into having arguments to the function, checking those types, and having scopes for the function body itself, have the variables, all kinds of very, very nice things. But all that will be later, and that will be it for today. So thank you very much for watching, and hopefully see you next time.